There's a three systems of equations. You got three equations, three unknowns. Let's try to use this technique called augmented, using an augmented matrix. All right, augmented matrix. All right, so that idea, the word augmented, to change, to adjust. All right, so we're going to adjust this matrix. Remembering what we said earlier, you can multiply any of these equations by anything you want, and you're not really changing it. You're not really changing the matrix. So we're going to augment a portion of this matrix to look like 1, 0, 0, 1, 1, 0. All right, so we want, actually, we're going to focus. What we're going to do is we're going to try to simplify this matrix so that we get a 1 here, a 0 here, a 0 here, and a 1 here. And technically, this really doesn't have to be a 1. But one of the things that I'd like you to notice is if we can get a 1 here, 0 here, 0 here, and a 1 here, we want these numbers here to look like that. You'll see that simplifies the problem significantly and allows us to solve for these variables much easier than you have originally. All right, so let's just jump right into it. So I'd like you to attack this matrix starting in the upper left-hand corner and traveling down that way, sort of attacking the problem from this L formation. All right, so we're going to we want that to be a 1. We want this to be a 0. We want this number here to be a 0. We want this number here to be, a 1. But I think we'll discover that we don't have to attack this here. And you'll see what I mean in a minute. All right, so let's start out. We want this number here to be a 1. All right, so one thing that we could do here is multiply this entire equation by half. And we talked earlier in the show how it's legal to multiply an entire equation by whatever you want, and you're not changing it. So one of the things I'd like to show you is let's multiply this entire equation by half. And again, the reason why we're multiplying it by half is because we have a desire for this to be 1. All right, so we're going to take equation 1, and multiply it by half because of our desire to model this, get this L here to look like that. All right, so what we end up is multiplying by half. We multiply 2 by half, we get 1. We multiply 4 by half, we get 2. We multiply 5 by half, we get 5 halves. And we multiply this 5 by half, we get 5 halves. And what we're going to do is bring the rest of our problem down. Bring down the 1, the 3. Let's give ourselves a little bit more space. 1, 3, 3, 2. Just bringing the problem down. And here we have 2, 4, 4, 2. All right. So, all right. Now what we're going to do is we're going to attack this number here because I told you we're going to attack each of the numbers so we can get a 1 here, a 0 here, and a 0 here. So we're going to go in order of this L shape that I've tried to configure here. So we want that to be 0. In other words, we want this X, we want this number here to be 0. All right, so the way we can do that is just by subtracting. We can subtract equation 1 and equation 2. All right, so we're going to subtract. We're going to take equation 1, subtract equation 2. All right, and that'll give us 0 because 1 minus 1 is 0, and that's going to represent our new second row. So let's rewrite our first row. We get 1, 2, 5 halves, 5 halves. We're going to take equation 1, subtract equation 2, and if we do that, We get 1 minus 1 is 0. We get 2 minus 3, which is a negative 1. Let's give ourselves a little bit more space. All right, so we get 0, negative 1, and now we get 5 halves minus 3, or another way to say 3 is 6 halves. 5 halves minus 6 halves, which is a negative 1 half. All right, and here we have 5 halves minus 2. Another way to say 2 is 4 halves. 5 halves minus 4 halves is 1 half. So we just subtract it. And let's leave this third row the same. We get 2, 4. Uh-oh, you can't see that. I'm just leaving this third row the same. We get 2, 4, 4, 2. All right, so what have I done? I got a 1 here and a 0 here, just like I desire. I got a 1 here, 0 here. Next number I'm going to subtract, or excuse me, next number I'm going to attempt to augment is this 0 here. This is Z. I want that to be 0. So I'm going to attack that 2. I'm going to attack that 2. All right, so how can I get 0 here? All right, so what I'm going to do is I am going to multiply this top row by 2 because that is a 2. In fact, what I think I'll do is I'll multiply this top row by negative 2 just to add, because a lot of my problems that I've been doing a lot of subtracting. I'm just trying to make a point that you can either add or subtract. I mentioned that earlier in the show as well. So let's take 2 times equation 1, or negative 2, excuse me, times equation 1 and add it to equation 3. And add it to equation 3. In an attempt to get a negative 2 here, I have a positive 2 here. If I add a negative 2 and a positive 2, that will give me 0, which is what I desire. That's what I desire right there. That's going to be my new third row. All right, so let's go off to the side, multiply negative 2 times equation 1, multiply negative 2 times that 1, I get a negative 2, multiply negative 2 to that, I get a negative 4, negative 2 here, I multiply 5 times a negative 2, and I get a negative 5. I multiply negative 2 times 5 halves here, and I get a negative 5 again. If I multiply this times a negative 2, the 2's will cancel, and you would get a negative 5. Well, what I'm going to do is I'm going to add that to equation 3. Equation 3, that's 2. That is 4, 4, and 2. So I'm going to add these two equations together and get a new row 3. All right, so let's keep the first row and the second row the same. We get 1, 2, 5 halves, and 5 halves. Keep the second row the same. 0, negative 1, negative half, and half. All right. And then I'm going to add these two. I'm going to add these two rows here and get my new third row. Add negative 2 plus 2, that's 0. And then we'll add negative 4 and 4, that's 0. Add negative 5 plus 4, that's negative 1. And add negative 5 plus 2, we would get negative 3. All right. So it turns out, if you notice, I was initially attacking the 2 and making that 0. I wanted to make that 0. But it turned out that actually up here, I think I might have told you something that wasn't entirely correct. What we really wanted to do with this augmented approach is to make this a 1, this a 1, and actually this a 0, and that a 1. That doesn't really affect our problem, but just to be technically correct, you really want this to be 1, 1, 1 here, and then zeros everywhere everywhere else. Sorry about that. I'm hoping I didn't confuse anyone. And the point I was going to make is I was attacking this 2 because I wanted that to be 0. And it turned out that we sort of, we wanted both these to be 0, but in one step, I made both 2 0 and the 4 0. So though I was only attacking the 2, it turned out that both these, in this one step, both these became 0, and that actually simplifies our problem significantly. So now what we can do is we can just begin to solve this problem. All right, so this is the X column, Y column, Z column. So another way of looking at this is negative Z, negative 1Z is equal to negative 3. Negative 1Z is equal to negative 3. You divide by negative 1 on both sides, and you get 3. Z is 3. All right. So now what you can do here is look at this second row. Look at this second row, and you get, this is the Y column, so you get negative 1Y minus 1/2 Z, that negative 1/2 is in the Z column, is equal to half. All right, and realize that you know what Z is. Z is 3. So you get negative 1Y minus 1/2 times your value for Z, which is 3, is equal to half. All right, so now you end up with negative 1Y minus 3/2 is equal to 1/2. You end up with negative 1Y, and you end up adding 3/2 of both sides. You end up with 4/2, which is just 2, and you're going to get Y is equal to negative 2. Y is equal to negative 2. All right, so you get Y is negative 2, Z is 3. And now what you're going to do is you can put Z and Y, 3 and negative 2, into either original equation. In the past, in a previous problem, we substituted the variables into the second equation just to make a point and to show you it really did not matter what equation we substituted Y and Z into. What I'd like to do is substitute in Y and Z into another equation. Let's try the third equation. All right, so we get 2x, all right, 2x plus 4y plus 4z is 2. And let's substitute these variables, or actually these, these solutions into this new equation, which represents one of the original equations. All right, so we get 2x plus 4 times y. Y we found to be negative 2, plus 4 times z we found to be 3. That's 2. And we get 2x minus 8 plus 12 is 2. We get 2x plus 4. 2x plus 4 is 2. We get 2x is a negative 2 by subtracting 4. And we get x is a negative 1. X is a negative 1. So, again, we get negative 1, negative 2, 3. And that is the same answer we got previously. Negative 1, negative 2, 3. Another problem. Negative 1, negative 2, 3. Mastery level understanding. My students can do that. In fact, my students just took their final exam. They took their final exam yesterday, and they dominated. Do you think if they can solve the same problem in 3 different ways, you think they're going to do well on their final? The answer is absolutely. Absolutely, they'll do well on their final because they're about domination. We're not about just solving the problem in one way. My students can solve the problem in 2, 3, sometimes 4 different ways. And this is what I'm encouraging our students to do. Students, the name of this show is called Students Dominate Math. This show is not called Students Pass Math. This show is not called Students Try It Math. This show is called Students Dominate. It's beautiful. Our students can dominate. We just got to put a demand on them. All right, so now